Hello students and good morning. So now I am doing class for class 11. The topic is the same topic that we were doing in the last online class. That is, the topic is trigonometrical ratios of compound angles. So today is the continuation class of this chapter. Same exercise 4, 2 mark section, page number 139 from the book Higher Mathematics for class 11 by SN Day. So let us do this question number 5 from 2 marks section. So if sin theta is equal to 3 upon 5 and tan phi is equal to 8 upon 15 and theta and phi lie in the first and the third quadrants respectively. That means theta lies in the first quadrant and phi lies in the third quadrant. So if theta lies in the first quadrant, all the trigonometrical ratios are positive, but phi lies in the third quadrant, and in the third quadrant only tan and cot are positive, but all other trigonometrical ratios are negative in this case. Okay, in the third quadrant only tan and its inverse, that is cot theta, are positive. That is, phi lies in the third quadrant. That means tan phi and cot phi are positive, but all other trigonometrical ratios are negative in the third quadrant. So you have to get the value for cosec theta plus phi. So there is no formula for cosec theta plus phi, but you know the formula of sine of a plus b, isn't it? So let us convert this cosec theta plus phi in terms of sine. That is 1 upon sine of theta plus phi, and you know the formula of sine theta plus phi, that is sine of a plus b. Sine a cos b plus cos a sine b. Similarly, it is sine theta cos phi plus sine theta cos phi plus cos theta sine phi. So you have to get the value for sine theta cos phi, sine theta cos phi, cos theta and sine phi from the given values of sine theta and tan phi. Okay, so here given is sine theta is equal to 3 upon 5. Now from here you have to get the value for cos theta, and since theta lies in the first quadrant, so sine theta is positive and cos theta is also positive in the first quadrant. So directly you can get the value for cos theta. So cos theta is equal to, what is the formula? It is root over 1 minus sine square theta. It is positive. Positive is square root of 1 minus sine square theta, because cos theta is positive in the first quadrant. Okay. So or cos theta is equal to root over 1 minus, this is 3 by 5 whole square, or now this is cos theta is equal to root over 1 minus 9 by 25, or cos theta is equal to, this is within square root, 25 ones are 25 minus 9, what is it? 16 by 25, or so what is cos theta now? Square root of 16 is 4, square root of 25 is 5, that is 4 upon 5. So we have got the value for cos theta, which is equal to 4 upon 5, from the value of sin theta, which is 3 upon 5. Okay. Now what is given here? Now again, what is given in this case? Tan phi is equal to 8 upon 15. Okay. So here phi lies in the third quadrant. And in the third quadrant, tan and cot are positive, but all other trigonometrical ratios are negative in the third quadrant. But from tan phi also you have to get the value for both sin phi as well as cos phi. Okay. So let us square both the sides. Why are we squaring both the sides in this case? If we square both the sides, you will get tan square phi. And from tan square phi, you can easily get the value for sec square phi. And from sec square phi, you can easily get the value for cos phi. Okay. So let us square both the sides. Squaring both the sides. So squaring both the sides. So what do we get? This is tan square phi is equal to 8 whole square is 64. 15 whole square is 225. Okay. What is tan square phi in terms of sec? It is sec square phi minus 1 is equal to 64 divided by 225, or what is the value for sec square phi is equal to now minus 1 is taken to the right hand side. It is 1 plus 64 by 225. Okay, or what is sec square phi is equal to, now this is 225, ones are 225 plus 64. How much is it? 289 divided by 225. Or what is sec phi is equal to, it is square root of 289 divided by 225. Both the sign, you have to write down both the sign here, plus minus. Okay, it is sec phi is equal to plus minus. You have to write both the sign now, and you have to check the correct sign for sec phi. Okay, so sec phi is equal to, it is both the sign. You have to write both the sign here, plus minus root over 289 divided by 225. Is that clear? Or sec phi is equal to, this is plus minus, what is square root of 289? It is 17. What is square root of 225? What is square root of 225? It is 15. This is your 15. So we have got the value for sec phi. Okay, but which is the correct sign here? Since phi lies in the third quadrant, and in the third quadrant sec phi is always negative. Since phi lies in the third quadrant, therefore sec phi is negative. Sec phi is negative. Okay, so which is the correct sign for sec phi? So sec phi is equal to minus 17 upon 15. So sec phi is equal to minus 17 upon 15. Okay, now from sec phi you can easily get the value for cos phi. So cos phi is just the opposite of sec phi. So what is cos phi now? So cos phi is equal to minus, it is 15 by 17. So what is cos phi is equal to? It is just the opposite of sec phi. So cos phi is equal to minus 15 by 17. So we have got the value for cos phi. Now we have to get the value of sin phi. Okay, now you know that tan phi is equal to sin phi upon cos phi. Okay, or what is tan phi here? It is 8 by 15. It is 8 by 15 is equal to, this is your sin phi divided by what is cos phi? Minus 15 by 17. Is that clear? So what is the value for sin phi now? So sin phi is equal to, it is cross multiplied, 8 by 15 into minus 15 by 17. So 15 gets cancels. So what is sin phi is equal to now? What is sin phi is equal to minus 8 by 17. So we have got the value for sin phi also. So sin phi is equal to minus 8 by 17. So sin phi is minus 8 by 17, cos phi is minus 15 by 17, sin theta is equal to 3 by 5, and cos theta is equal to 4 upon 5. Now let us get the value for what? Cosec theta plus phi. So therefore, now let us get the value for cosec theta plus phi. So in the question, it is asked to find out the value for cosec theta plus phi. So now what is cosec theta plus phi? It is 1 upon, it is just the opposite of sine. It is sine of theta plus phi, right? So which is equal to 1 upon, what's the formula? Sine of a plus b. Sine theta cos phi plus cos theta, then sin phi. So let us put those values now. 1 upon, what is sin theta? What is sin theta here? 3 upon 5. So let us write here 3 upon 5 into, what is cos phi? What is cos phi? It is minus 15 by 17 plus minus 15 by 17 plus what is cos theta? 4 by 5. 4 by 5 into what is sin phi? It is minus 8 by 17. So I think you have understood it. Okay. So in the next step, now let's simplify it. So we can simplify it further now. So let us simplify it now. So which is equal to 1 upon, this is 1 upon, how much is that? Minus 15 3s are 45. Minus 45 divided by 7 5s are 85. Then next, plus and minus, minus 8 4s are 32 divided by 7 and 5s are 85. Is that clear now? So let's simplify it. 1 upon, what's the LCM? This is 85. So here it is minus 45 minus 32, which is equal to 1 upon, this is minus 77 divided by 85, which is equal to, now when it goes up in the numerator it becomes upside down, so it is minus 85 divided by 77. So this is the final answer. So I think you have understood it. Okay, so you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 2. Let's do 6. Number 6, prove that question number 2. Question number 1 is your homework. You can do it at home. Cos 20 plus sin 20 divided by cos 20 minus sin 20 is equal to tan 65 degree. You can prove it from right hand side also. Okay. So here RHS is equal to tan 65 degree. This 65 degree can be written in terms of 20 degree by writing it as 45 degree plus 20 degree. Then you can use tan of A plus B. Okay. So prove it from right hand side. That is RHS is equal to LHS. So this is your homework. So let's do this question number 2. You have to prove that cosec within bracket theta plus phi is equal to cosec theta into cosec phi divided by cot theta plus cot phi. So let us prove it from left hand side now. So LHS is equal to, this is cosec within bracket theta plus phi, which is equal to, but we don't know the formula of cosec A plus B, but we know the value for, we know the formula for sine of A plus B, isn't it? So let us change it into sine. So this is 1 upon sine, this is theta plus phi, which is equal to, now what is this sine of A plus B? So it will be 1 upon sine of A plus B is sine theta cos phi plus cos theta sine phi. Is that clear now? So now you have to convert this expression in the form of cosec theta cosec phi divided by cot theta plus cot phi. So you should prove in the numerator cosec theta cosec phi. How can you prove cosec theta into cosec phi? It should be divided by sin theta into sin phi, because we know 1 by sin theta is cosec theta and 1 by sin phi is cosec phi, isn't it? That means you have to divide both the numerator and the denominator by sin theta sin phi. So let us write here, dividing both the numerator and the denominator by how much? By, since we have to prove cosec theta cosec phi in the numerator, you should divide the numerator and the denominator by sin theta sin phi, by sin theta sin phi. Okay, so let us divide both this numerator and the denominator by sin theta sin phi, which is equal to 1 upon, this is sin theta sin phi, upon, in the denominator you can separate the term sin theta cos phi divided by, this is sin theta sin phi, plus, next second term is also divided by sin theta sin phi, so it is cos theta sin phi divided by sin theta sin phi, sin theta sin phi. Okay, So here we can cancel this sin theta and here we can cancel this sin phi, which is equal to, what is 1 by sin theta? It is cosec theta into what is 1 by sin phi? It is cosec phi. This divided by, now in the denominator, what is cos phi by sin phi? It is cot phi, plus what is cos theta by sin theta? It is cot theta. So it is proved. So I think you have understood it. So we have proved the result, that is cosec theta cosec phi divided by cot theta plus cot phi, and cot phi plus cot theta is same as cot theta plus cot phi. So it is proved. Is that clear? So now we can copy it. Now we'll do the next question. So now we'll do the next question, that is number 6.3. Prove that cos 67 degree 24 minutes, you know that this is 24 minutes, cos 7 degree 24 minute plus cos 82 degree 36 minutes cos 22 degree 36 minutes is equal to half. You have to prove this left hand side is equal to half. So let us write down here left hand side. So LHS is equal to cos 67 degree 24 minutes cos 7 degree 24 minutes plus cos 82 degree 36 minutes cos 22 degree 36 minutes. Okay, so you have to convert it into formula like cos A cos B plus sin A sin B. Let us change the second term into sine. Both the cos are changed into sine now. So both these cos are changed into sine. Let us change this cos into sine now. So you know the formula. How can we change this cos theta into sine theta? Cos theta can be changed into sine by writing sine 90 degree minus theta. Okay. So let us keep the first term as it is, cos 67 degree 24 minutes cos 7 degree 24 minutes plus, let us change this cos into sine by writing sine 90 degree minus 82 degree 36 minutes. Again this cos is changed into sine by writing sine. This is your 90 degree minus 22 degree 36 minutes. So is that clear? So let us simplify it, which is equal to cos 67 degree 24 minutes cos 7 degree 24 minutes plus sine. So how can you subtract this 82 degree 36 minutes from 90 degree? So let us write here, this is 90 degree and you have to subtract 82 degree 36 minutes from this 90 degree, right? So this 82 degree 36 minutes should be subtracted from 90 degree. Okay, so you cannot subtract it. So you can subtract it by writing 90 degree can be written in terms of 89 degree and 1 degree, isn't it? And you know that 1 degree means 60 minutes. So it is 60 minutes. So subtract 82 degree 36 minutes from this 89 degree 60 minutes or 90 degree. Okay. So this 90 degree can be written as 89 degree and 1 degree, because you know that 1 degree is equal to 60 minutes. So this 90 degree can be written in terms of 89 degree 60 minutes. In order to subtract this 82 degree 36 minutes from 90 degree, this 90 degrees should be written in terms of 89 degrees 60 minutes. So let us subtract it. 10 minus 6 is 4. This is 5 minus 3 is 2, 24 minutes. And this 9 minus 2 is 7 degree 24 minutes. So it is 7 degree 24 minutes. Okay. Then again there is sine. Similarly, you can subtract 22 degree 36 minutes from 90 degree. Again, this 90 degree can be written as 89 degree plus 1 degree. That is your 90 degree. But that 1 degree should be converted into minute. That is 60 minutes. Then subtract 22 degree, 36 minutes from this 89 degrees, 60 minutes. Okay. So let's subtract it. 10 minus 6 is 4. This is your 5. 5 minus 3 is 2. 9 minus 2 is 7. 8 minus 2 is 6. So it is 67 degree 24 minutes. So it is 67 degree 24 minutes. Is that clear now? So I think you have understood it. So now this is the formula. 67 degree 24 minutes can be taken as A, and this 7 degree 24 minutes can be taken as B. So this is cos A cos B plus sin A sin B. What is the formula? Cos A cos B plus sin A sin B is equal to cos of A minus B. So which is equal to cos, this is 67 degree 24 minutes minus 7 degree 24 minutes, which is equal to, now cos 24 minutes minus 24 minutes, 0 minutes, you don't have to write it. 67 degree minus 7 degree is cos 60 degree. Now this is the standard angle, 60 degree. What is the value for cos 60 degree? It is half. So it is proved. So I think you have understood it. Okay. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 6. Prove that this is question number 4. So let us prove this LHS is equal to RHS. You have to prove tan of B minus C plus tan of C minus A plus tan of A minus B is equal to tan of B minus C into tan of C minus A into tan of A minus B. You have to prove it. So in this case, if you want to prove from left hand side, it will be complicated. Okay, so in this case you have to use the different methods in order to prove this LHS is equal to RHS. So let us assume this B minus C as X. Let B minus C is equal to X, right? Then next let C minus A is equal to what? Y. Then let A minus B is equal to what? It is Z. Okay. So let us assume this first angle B minus C as X, C minus A as Y, and A minus B as Z. So let us add them. If you add this left hand side, A will be cancelled, B minus B will be cancelled, C minus C will be cancelled. That means it will be 0, which is equal to, on the right hand side, it is X plus Y plus Z. That means all these are added. Left hand sides are added, right hand side also added. Okay. So right hand side will be X plus Y plus Z, which is equal to 0. Or you may write it as X plus Y plus Z is equal to what? It is 0. Okay. Now take one of the terms to the right hand side and then take tan on both the sides. You have to take tan on both the sides because you have to prove in terms of tan. So you have to take tan on both the sides. Before that, take one of the terms to the right hand side and then take tan on both the sides. Okay. So or this is X plus Y is equal to minus Z. Now you have to take tan on both the sides. So it is tan of within bracket X plus Y is equal to tan of within bracket minus Z. Is that clear? So on the left hand side, which formula is used? Tan of A plus B is used, isn't it? So what is the formula? It is tan X plus tan Y divided by, that is tan of A plus tan of B divided by 1 minus tan A tan B, that is 1 minus tan X tan Y is equal to, now on the right hand side, what is tan of minus theta? It is minus tan theta, isn't it? So you can write here minus tan Z. So below this minus tan Z there is 1. So let us cross multiply. Let us do cross multiplication. So 1 is multiplied by tan x plus y. So it is tan x plus tan y into 1 is tan x plus tan y is equal to. So let us cross multiply by minus tan z. What do we get? 1 into minus tan z. 1 into minus tan z is minus tan z. Minus tan z, right? Then again this minus into minus plus tan x tan y tan z. So this is plus tan x tan y and this is your tan z. Is that clear? Now let us take this minus tan z to the left hand side. So it becomes, this is tan x plus tan y plus tan z is equal to, on the right hand side you can write tan x tan y tan z. Is that clear? So I think you have understood it. Now you can put those values of x, y and z in order to prove this LHS is equal to RHS. Okay. So, or tan of, what is the value for x? It is b minus c. B minus c plus tan of, what is y? Y is c minus a, isn't it? Y is equal to c minus a. So this is c minus a plus tan of, within bracket, what is z? It is a minus b. So this is a minus b is equal to, on the right hand side also you can put those values of x, y and z. What is x here? B minus c. So it is tan of b minus c. So this is tan of b minus c. Tan of, what is y? C minus a. Then tan of, what is z? It is a minus b. So it is tan of a minus b. So it is done. It is proved, isn't it? Tan of b minus c plus tan of c minus a plus tan of a minus b is equal to tan of b minus c, tan of c minus a, tan of a minus b. So it is done, proved. So we have proved it. Okay. So I think you have understood it. This is the method for doing this problem number 4, that is LHS is equal to RHS. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 7. You have to prove that the value of each of the following expressions is independent of theta. So what is the meaning of independent of theta? So after simplification of the given expression, there should not be no term containing theta. Okay? After simplification of the given expression, there should not be no term containing theta. तो जुन चाहिँ एन्सरमा आउनु पर्छ त्यो एन्सरमा चाहिँ थीटा हुनु चाहिँ भएन. It should be independent of theta. That is, the answer of this question, the answer of these two questions must be independent of theta. Okay. So you have to prove that the value of each of the following expressions is independent of theta. So you have to find out the value of this expression, and in the answer should be independent of theta. There should not be no term containing theta after simplification of these two expressions. Okay. So let's do this question number 1. So within third bracket we have here cot of pi by 4 minus theta minus 1. Third bracket is closed into cot theta minus 1. So let us simplify it. So which is equal to, within third bracket now here, this is the formula cot of a minus b. What is the formula cot of a minus b? Cot a cot b plus 1 divided by cot b minus cot a. So it is cot theta minus cot pi by 4. Then write down minus 1. Okay. So that is the formula cot of a minus b. Cot a cot b plus 1 divided by cot b minus cot a. Here a is pi by 4 and b is theta. Okay. Then third bracket is closed. Cot theta minus 1 is kept as it is, right? So which is equal to, within third bracket, what is cot pi by 4? That is your 1. So 1 into cot theta is cot theta plus 1 divided by, this is cot theta minus, what is cot pi by 4? That is also 1. Minus 1. Third bracket is closed. Within bracket cot theta minus 1. Okay, so let us simplify it. So what's the LCM out here? It is cot theta minus 1 is the LCM. So in the numerator we have, this is cot theta. This is your cot theta, isn't it? So this is your cot theta. This is your cot theta. Cot theta. So let us write here. This is your cot theta plus 1 minus, let us multiply it, minus 1 into cot theta minus cot theta, minus into minus plus 1, third bracket is closed, into this is cot theta minus 1. Okay, so from here you can cancel this cot theta minus 1, that is your 1, and here cot theta gets cancels, which is equal to, what is the answer? The value of this expression is 2. So which is independent of theta? Which is independent of theta? So it is proved. That is, this value 2 is independent of theta. So that is the answer. We have proved it. Okay. So I think you have understood it. You can copy it. So now let's do this question number 2. So in this question number 2 also you have to find out the value of this expression, and the value of this expression should be independent of theta. That is, there should not be no term containing theta after simplification of this expression. Okay. So in this case we can use this formula. That is cos square A minus sin square B. What is the formula? The formula is cos of A plus B into, this is cos of A minus B. So you should know it. We have done this formula at the beginning of this chapter, that is trigonometrical ratios of common angles. We have done this formula. You can check that. You can compare that one. Okay, you can check that formula. You can revise that formula, that is cos square A minus sin square B is equal to cos of A plus B into cos of A minus B. Okay, so you can revise that formula, right? So which is equal to, here A is pi by 4 plus theta, and what is B? Pi by 4 minus theta. So what is cos of, what is A? It is pi by 4 plus theta, plus what is B? It is pi by 4 minus theta. Is that clear? That is your cos of A plus B. Then what is cos of A minus B? A is pi by 4 plus theta. What is minus B? Minus pi by 4, minus into minus plus theta. Is that clear? So this is the formula that you should know, right? So which is equal to, here theta gets cancels. So this is, what is cos pi by 4 plus pi by 4? That is your 2 pi by 4. Which is equal to pi by 2, that is your cos pi by 2, and here this pi by 4 will be cancelled. You will get cos theta plus theta is 2 theta, which is equal to, what is the value for cos 90? Pi by 2 is 90, isn't it? Cos 90 is 0 into cos 2 theta. So what is the value of this expression? That is 0, which is independent of theta, which is independent of theta. So it is done, proved. Is that clear to all of you? I think you have understood it. We are using the formula of, in this case we are using the formula of cos square A minus sin square B, which is equal to cos of A plus B into cos of A minus B. So here A is pi by 4 plus theta, and here B is pi by 4 minus theta. So this is cos of A plus B, and this is cos of A minus B, and then simplify it and you will get 0, which is independent of theta. Okay, so I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 8. If cos of alpha minus beta bracket close plus 1 is equal to 0, then prove that cos alpha plus cos beta is equal to 0 and sin alpha plus sin beta is equal to 0. So what is given in the question? cos of alpha plus beta, bracket close, plus 1 is equal to 0. It is given that you have to prove that cos alpha plus cos beta is equal to 0 and sin alpha plus sin beta is equal to 0. Okay. So let us write down here given is cos of alpha minus beta plus 1 is equal to 0, or cos of alpha minus beta is equal to minus 1. Okay. So what is the value for cos of alpha minus beta, which is equal to minus 1? Okay. So now in this case you should know this relation. If a square plus b square is equal to 0, when is this equation possible? What are those values of a and b? You know that whatever may be the value for a, whether it is positive or negative, a square is a positive quantity. Similarly, whatever may be the value for b, whether it is positive or negative, b whole square is also a positive quantity. So positive quantity plus positive quantity is not equal to 0. You know that, isn't it? So this equation is possible if the individual values of a and b is equal to 0. So this equation is possible only if a is equal to 0 and b is equal to 0. Then only we can prove this LHS is equal to RHS. That is 0 whole square is 0 plus 0 whole square is 0. 0 plus 0 is equal to 0. Isn't it? So if a square plus b square is equal to 0, it implies that a is equal to 0 and b is equal to 0. Okay. So now in this case, in order to prove that cos alpha plus cos beta is equal to 0 and sin alpha plus sin beta is equal to 0, let us first find out the value for both cos alpha plus cos beta whole square plus sin alpha plus sin beta whole square. So let us find out this value first. Okay. So now in this case we have cos alpha plus cos beta whole square plus sin alpha plus sin beta whole square. So let us find out the value of this expression first. Okay. So which is equal to, you know that a plus b whole square is a square plus 2ab plus b whole square. So it is cos square alpha plus twice ab 2 cos alpha cos beta plus what is b whole square? It is cos square beta plus. Similarly, sin alpha plus sin beta whole square is also a plus b whole square, isn't it? So it is sin square alpha plus 2 sin alpha sin beta plus this is sin square beta. Is that clear to all of you? So now let us simplify it. Cos square alpha plus sin square alpha. Let us write it together. Cos square alpha plus sin square alpha plus. Similarly, let us write them together. Cos square beta plus sin square beta. Cos square beta plus sin square beta. Let us write it together. And now from this second and fifth, what is common? 2 is common, isn't it? So 2 is taken common. So within bracket we have cos alpha cos beta. It is cos alpha cos beta plus this is sin alpha sin beta. Is it clear now? So let us simplify it. What is cos square alpha plus sin square alpha? That is 1. Plus what is cos square beta plus sin square beta? That is also 1. Plus 2 into, what is the formula that you can use here? Cos A cos B plus sin A sin B. Instead of A there is alpha, instead of B there is beta. So what is the formula? It is cos of alpha minus beta. Okay. So here 1 plus 1 is 2 plus 2 into, what is the value for this cos of alpha minus beta? It is minus 1. So which is equal to 2 minus 2 is equal to 0. Okay. So this 0 is the value for what? Cos alpha plus cos beta whole square plus sin alpha plus sin beta whole square, which is equal to 0. Let us write it here now. Therefore, we have just proved that cos alpha plus cos beta whole square plus sin alpha plus sin beta whole square is equal to 0. Let us write it here. So it is cos alpha plus cos beta whole square plus sin alpha plus sin beta whole square is equal to 0. Now in this case, whatever may be the value for cos alpha plus cos beta, whether it is positive or negative, because of this whole square it will be positive always. Here also sin alpha plus sin beta, whatever may be the value for sin alpha plus sin beta, whether it is positive or negative. If it is positive or negative, if it is whole square, it is always a positive quantity. This positive quantity plus positive quantity is not equal to 0. This is never equal to 0, isn't it? So this equation is possible if the individual values within whole square is 0. So this equation is possible if cos alpha plus cos beta is equal to 0 and sin alpha plus sin beta is also 0. Similarly, here also I explained you about this one. If a square plus b square is equal to 0, it implies that a is equal to 0, b is equal to 0. Similarly, here also this implies that, what does it imply? Cos alpha plus cos beta is equal to 0, and what? And the other one is sin alpha plus sin beta is also 0. So I already explained you that whatever may be the value for cos alpha plus cos beta, whether it is positive or negative, because of this whole square, this is always a positive quantity. Similarly, whatever may be the value for sin alpha plus sin beta, whether it is positive or negative, because of this whole square, this is also a positive quantity. So positive quantity plus positive quantity is not equal to 0. Is that clear? So this equation is possible. This is equal to 0 if individual value, that is cos alpha plus cos beta is equal to 0 and sin alpha plus sin beta is equal to 0. So this implies that, this equation implies that cos alpha plus cos beta is equal to 0 and sin alpha plus sin beta is equal to 0. So we have proved it. Okay, so it is done, proved. So you can write here proved. So I think you have understood it. So you can copy it now. This much is for today. As I made jati pani problems haru garyo, you revise all the problems that we did today and you do the homework also. And in the next online class, we will do more problems on this chapter, that is trigonometrical ratios of compound angles. So this much is for today.